Hello everyone, welcome to lesson number 23 for BC Calculus. This is where we're going to start talking about Taylor and Maclaurin polynomials. This is going to be one of the central focuses that we're going to be doing when we get to our last unit of the course with sequences and series. So I wanted to talk about really quickly the formula that you guys need to know for a Taylor and Maclaurin series. A Maclaurin series is really where the center, the C here is 0. So a lot, and you guys can see it, down here for this. So C is going to be the center of our series, and usually they'll tell us what that is. But if it says Maclaurin series, it's always at 0, and we have a much easier equation that we have to deal with. But really what happens is that you're going to take you're going to plug the function in, and then you're going to go ahead and add the derivative times the x minus c to the first all over 1 factorial. So whatever the power is will always be the factorial. And then same thing with the derivative. So if I look at my third term, I'm going to do plus, and it's going to be the second derivative, x minus c squared all over 2 factorial. So that's actually really easy for students to remember. And then we're going to add their third derivative, x minus c to the third power. Again, c is the center that you're going to see over 3 factorial. And so when we go to the nth derivative, it's going to be to the nth power and to the n factorial. So it actually ends up being pretty straightforward. So these are the formulas, and we're going to go ahead and get started and show you guys how to do the problems. And what I would like to talk about really quickly again is Maclaurin is where C is 0. And we're going to start with that knowledge. We're going to start with those first. The first thing I want you guys to know here is that there are lots of Maclaurin and Taylor series for polynomials. And really what Maclaurin and Taylor series does is they're taking stuff that may be a little bit more challenging to integrate and be able to rewrite it in any polynomial form. The more terms you have, the better it fits the curve. It's actually a really cool thing that I'll show you guys in this lesson, what's going on. But the first thing that we want to do here is that there are many polynomials, as I just said. We're going to focus on 3 of them in this particular lesson. We're going to talk about the cosine of x, we're going to talk about the sine of x, and 1 over 1 minus x, which is going to be very similar to 1 over 1 plus x. So let's go ahead and get started with this and show you guys how to rewrite cosine of x into a polynomial using the Maclaurin polynomial series. So what we're going to do really quickly is, again, we're just going to start out very basic with Maclaurin's polynomials. So the c is going to be equal to 0. So you guys can see that we've already typed in, or I've already written in, the formula for this. Now this is something that you will be able to memorize. It's actually pretty awesome what happens with these. And just like with sine, cosine is going to have a pattern. So after you do a certain amount of derivative, you're going to see the same thing back over. So the first part of this, so cosine of x, we're going to plug in f of 0 first. So we're going to go ahead and plug in f of 0. So our very first term that's right here is going to be 1. So this is going to be 1, right? Cosine of 0 is going to be 1. Then we want to find the derivative of cosine. So the derivative of cosine is going to be negative sine of x. All right, and now like I said, we're deriving this right now, and then eventually you guys are going to memorize what you see down here. So we take our derivative and we're going to plug in 0 to this. So this is going to be negative sine of 0. Well, sine of 0 is always going to be 0. So down here, it's going to be plus 0 times x. And again, we will simplify this a little bit later on as we move along. Now we want to take the second derivative. So we want to take the derivative of our derivative. So we want to take the derivative of negative sine, which is going to give us negative cosine of x. And then we want to plug in our 0 into our second derivative, and that's going to give us negative cosine of 0, which is negative 1. So we're going to do negative 1 now. So again, we just found the second derivative, so it's going to be x to the second power all over 2 factorial. I mean, technically, if we want to be, we could have done this to the first power all over 1 factorial if we really wanted to. And so that's it. So we start, this is x to the 0 over 0 factorial, by the way, if you guys want to think about it like that, because x to the 0 is 1, and then 0 factorial is actually 1. So if we want to start it just kind of thinking it like that, right? We start at x equals 0 and just keep moving forward. All right, so we're going to take the third derivative, which is going to be the derivative of our second derivative. So negative cosine is going to be positive sine. And then if I plug in 0 to this, again, we're going to get 0. And so I'm going to go ahead and do plus 0. We just found our third derivative, so it's going to be x to the third all over 3 factorial. The reason that I keep talking about this, yes, it's 0, But a lot of times these are not going to be 0. So you want to just kind of keep mentality that it's going to be x cubed all over 3 factorial. And now to the fourth derivative, it's going to be sine again, the derivative of sine, which is going to be cosine. So we're going to start back over, right? We're going to cosine of 0 of x, which cosine of 0 is going to be 1. So then we're going to do plus, we're going to do 1 x to the fourth all over 4 factorial. And just to kind of go on a little bit further here, so we're going to do then plus 0 x to the fifth over 5 factorial. So I want you guys to see just kind of these things right here. And then remember that we would do a negative, so it'd be minus 1x to the 6 over 6 factorial. And then it would be a plus here, right? So plus 0 to x to the 7th over 7 factorial. And then plus 1x to the 8th over 8 factorial. And then we're going to do plus dot, 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 right? Plus dot, dot, dot. So let's look at this. Let's look at our problem right here and just start simplifying stuff out. So I'm going to go ahead and I'm going to erase some things for us. So the first thing is I'm going to erase any term that has a 0 on it. And then we're going to start looking at a pattern that you guys should hopefully see as I'm going about this. So, and this is why I did a couple of terms so you guys could see what's going on with this. All right, so what I'm going to do really quickly is pause the video. I'm going to push these things together. Okay, so I went ahead and just got rid of all of the zeros terms and then put them together. So the first thing I want you guys to notice here is that all of our powers are actually even. This is actually x to the 0 power. So all of our powers are even. And notice that the power, the exponent, the degree is actually equal to the factorial. And then the other thing is that we notice that all of our signs are changing. All of our signs are changing. So if we want a general term for this, what this actually is going to be equal to is we're going to go ahead and do negative 1 to the n power. And that basically, that's going to help us alternate our signs. So when n is equal to, we're going to start when n is equal to 0. Okay. So n is equal to 0. So we're going to have, negative 1 to the 0 power, which is going to give us a positive 1. When n is to the first power, then we're going to have a negative, like that. Then you guys can notice that if we start this, then it's going to be x to the 2n. So again, when x is equal to 0, we get 1. When x is 1, sorry, when n is 1, then we get the 2. When n is 2, we get 4, etc., etc. And it's going to be all over. And notice that the exponent is going to match this. So this is going to be 2n, and then we will do parentheses factorial, all right, to the n factorial. And so this is the general term for this. All right, I just wanted to move that up because it was bothering me with that. So this is going to be the general term for this. But you don't necessarily need to know any of this right this moment in time. Right now, what I want you guys to focus on is the fact that cosine is just going to be, and the other thing that I really like about cosine that helps students. So what strategy can we do for this? Well, if you guys remember what the cosine graph looks like, right? What the cosine graph looks like, it's actually an even function. Cosine is an even function. We talk about even and odd functions. It's symmetric to the y-axis. So that's how I always tell students to remember that all of your exponents for cosine is going to be actually even. All right. So now with that being said, let's go ahead and do the sine one, which it is an odd function. So you're going to see it's very similar to the cosine one. I do suggest that you guys actually pause the video if you need to and actually see if you can figure it out on your own, because I'm sure you can. And we have a little chart here to help you guys with these particular problems. But if you want to take a second, pause it, do it, and then unpause it, and I'll show you guys how to do the problem. Okay, so let's look at sine. So again, the first thing is it's going to be f of c, which again, c is 0. So f of 0 is 0. So we're going to go ahead and we're going to do 0 here. Now I'm going to go ahead and, since I got room, I can do it here. I was going to just ignore all the 0 terms, but let's just go ahead and do it here. So the derivative of sine is going to be cosine. So positive cosine of x. And we're going to go ahead and we're going to put a 1. So we're going to put 0 in here. We're going to get 1. So this was our first term, right? So it's going to be the first term. It's going to be x to the first all over 1 factorial. So everything in this term. So this is actually the second term. I should say that. It's not the first one. This is actually the second term that when we actually start talking about the series themselves. But it's the first derivative term. Let's call it like that. So it's the first derivative term. So everything's all about 1. So the first derivative to the first power over 1 factorial. Then if I find the derivative of cosine, I get negative sine of x. I plug in 0. So I plug in 0 to sine, I get 0 again. So this is going to be plus 0. Again, it was the second derivative, so we did 2 raised to the second over 2 factorial. I take the derivative of negative sine, I get negative cosine. I plug in 0, then I get negative 1. So it's going to be minus 1. Again, I used the third derivative, so it's going to be x cubed over 3 factorial. And then I go ahead and take the derivative of negative sine, which gives me back positive. Sorry, negative cosine, which gives me positive sine. And so again, I plug in 0. So I'm going to do 0x to the 4th over 4 factorial. Now I'm going to go ahead, you guys can see just like with the cosine one, that now only my odds actually have a number in front of it. If I want to go back and do the next term, then it would be plus 1x to the 5th over 5 factorial. So what I'm going to do is this. I'm going to go ahead and pause the video. I'm going to go ahead and get rid of all these zeros, bring them back together, and then show you again what to do. So I went ahead and just got rid of all the even powers and stuff like that. So if it asks us to do the first 5 terms, so I went ahead and did the first 3 terms here. So term 1, term 2, term 3. This, by the way, so just really quickly, I'm having a conversation about this. So this is 3 terms. So right now this is 3 terms with the degree of 5. So this is a polynomial of degree 5. So let's say we want to do 5 terms. Let's say we want to find 5 terms, and then we'll classify difference between terms and degrees. So remember that we do alternate signs. So this is just x to the 1st over 1, which again you guys know is x, minus x cubed over 3 factorial plus 5x over 5 factorial. So the next one's going to be negative, and it's going to be x to the 7th over 7 factorial. I don't need to put the 1 there, you guys understand that. And then if I'm going to do one more term, right, I want to find 5 terms, so 1, 2, 3, 4, I'm going to go positive because I'm changing signs. I'm going to get x to the 9th over 9 factorial. So what you guys see here is a polynomial representation. And before we end the video, I'm going to show you guys kind of what the point of this is. So sine of x is equal to this polynomial, x to the 9th over 9 factorial. So this is 5 terms, and the polynomial here is a degree of 9. So this is a degree of 9. Sometimes they're going to ask you to write a Maclaurin or Taylor series polynomial with maybe 5 terms, which again, it shows you all of these, or it may say a degree of 5. So 5 terms would be what you see right here. A degree of 5 would only be these first 3 terms right there that we started with. Okay, so let me show you guys something really quickly. Okay, so what I just did in the calculator for us was I went ahead and typed in sine of x, and then I went ahead and wrote out our 5-term degree of 9 polynomial in here as well. So if we graph this, so here's our sine graph, and now we only have 5 terms here, so you guys can see it both ways. So notice that when we graph this thing, look how it's going to now go ahead and trace exactly, this is a polynomial, and so it's going to trace it right now. Now you guys can see that it only covered from here to here. So if I add more terms, if we went to the 11th degree, then the 13th degree, the 15th degree, then it actually would continue to trace more and more and more. So the further down you go, the better you're going to get in a graph. But you guys can see that this is just a whole snapshot of actually the sine curve, which I think is actually really cool. Now what I want to do to finish this video up, because it's getting pretty long, is just to give you guys the general equation for this as well. So it's still, I'm going to do -1 to the n, because notice again, it's every even one that is, well, every even term, right? So 2, 4, it's negative. So again, I can do the -1 to the n. Just like up the top, I can do x, but now it's going to be to the 2x minus 1, right? 2x minus 1. And that's going to give us the first term, and this is when n equals 0, actually 2n plus 1, right? Sorry, so 2n plus 1. So if I plug in 0 here, I'm going to get 1. When I plug in n equals 1, I get 3. When I plug in 2, and again, this helps us with that. So n equals 2, I'm going to get 5, and then I can just do 2 to the n, 2n plus 1 factorial, and that's going to give us the general form for that. So that is the first part of sequences and series. We're going to be doing a ton of them throughout this year, ton of them. So we're going to come back and we're going to talk about one of my favorite ones, which is 1 over 1 minus x. We'll do that one next, and I'll see you guys in the next video.